You mentioned that refinery process crude oil into feedstock, not petrochemicals. Yes, Fahmi. You mentioned that refinery process crude oil into petrochemical feedstock, not but isn't diesel gasoline also considered petrochemical? No. I beg to differ, Fahmi, on the statement. So petrochemical, okay, for refineries, the product is basically more on energy. We're talking about energy, right? We need diesel to run the van, the truck. We need gasoline for the car, motorcycle. We need jet A1 for the aeroplane, right? For the aircraft. So this is all about energy. But for petrochemicals, the target client is different. That's why my approach in defining refinery product is basically energy. Related to energy stuff. But for petrochem, it can be more wide. It can be sent to the further downstream unit, which is chemical plant. So chemical plant can make use of the feed from petchem or petrochemical to produce a textile or pharmaceutical punya item. So it's different lah. It's a different concept. What is an aromatic compound? This is makeup. My first time hearing it. Is it like ethanol? No. Anand? I'm not sure. But I'm assuming you are not from chemical engineering background. So Anand, basically, to make it brief, aromatic compound is also okay. Sorry, maybe I can just write a bit. So normally for chemical engineering background, they are very familiar with this term, PONA. So this is basically crude. This is crude oil. What is P, what is O, what is N, what is A? P stands for paraffin, O is olefins, N is naphthens, A is aromatics. So these are the, I would say, a chemical structure that we can observe in the crude oil. And this P, O, and A will vary based on the cut point. So we have initial boiling point, right? Initial boiling point. We have final boiling point. So this is light, this is heavy. So normally, heavy will have a lot of A, midstream will have a lot of N. So this is, I would say, a brief punya understanding lah. It might not be accurate, but this is what PONA is lah in the crude. Hopefully menjawab. Anan. Civil. Sure, I try my best. What type of catalyst use? Okay, I didn't expect this kind of question. So talking about catalysts, for hydrotreaters, normally, if you're familiar with metals, so we have metals imbued in the catalyst. So just imagine a catalyst with a 6 mm size or bigger. So the base is designed. The base material is normally alumina. Don't ask me what alumina is. You can Google it later. The base is alumina, and then we have metal inside. So metal basically the active form of the catalyst. So when you ask me about what type of catalyst, catalyst is there's a lot of catalysts in the market right now, but what I can tell you is there are two main type of catalysts. We have noble metal, we have metal catalyst. So noble metal, talking about noble metal, we have platinum based, gold, palladium. So this is noble metal, and definitely the cost will be much higher. And then we have metal catalyst. So typically for hydrotreating catalyst, they only need a metal catalyst, a metal based catalyst. Okay, hopefully I answer your question. Saiful. Benzene ring. Okay, why?
Sir,
Yeah.
can you tell me how, I mean, the lifespan of the each catalyst we use for the hydrotreater? Is there any,
Mm.
any expected or predicted lifespan, or maybe what is your benchmark
Mm.
before we consider them as a way out catalyst?
Okay. In general, the reactor is designed to last at least until complete the turnaround cycle. I'm not sure if Sir Fazrul already mentioned this. So turnaround basically um, is a period where the refinery will undergo major maintenance, and typically the cycle typical refinery cycle is 4 years, but it can be more. So let's say from year 2000, it will run until year 2004. Kan? So there's a 4-year cycle, and in 2005 they will have this turnaround, major maintenance activity. So for the catalyst, typically the refiner will design the reactor at least to last this 4-year cycle. So
Okay, thanks.
how to make
Thanks.
it last? Okay, how to make it last? I mean the approach will be different. It can be, we have a bigger size of reactor. So bigger size reactor meaning more catalyst. So then it can last for 4 years cycle life. Or we can reduce the feed rate. Reducing the feed rate, we can operate the reactor up to 4-year cycle. But of course, it won't be beneficial. I mean, it won't be economical for the refineries. And so typically they will design the catalyst reactor, the reactor to at least last for 4 years. So it can go, it can undergo the maintenance activity lah after year 4 tu. All right.
Okay, so interesting. Thank you.
Okay. Welcome.